Okay, here is section 2.1, exercise 10. Same as exercise 6, we want to find the slope of the tangent line at 1, 5. So this is h of t is t squared plus 4t, and that's 1 and 5. And so notice on these exercises, they're getting us used to using letters other than f for the function name and other than x for the independent variable. It's just good to realize you aren't stuck with f and x. You can pick whatever you want. Okay, so here it's not so clear what that tangent line is like it was in 6, so we'll compute h prime at 1. And now, here's a funny thing, all right? I've got an h, so if I use an h, that would be a problem, right? So that wouldn't be good. So pick some other letter, so like I could use delta x in this case. Well, no, not delta x, but delta t. I guess I could still call it delta x, but it wouldn't make as much sense. So, I'm going to use maybe like a j. How about that? J, isn't that radical? J goes to 0 of h of 1 plus j minus h of 1 over j. And so this is the limit as j goes to 0. Now, again, be very careful about plugging things in. So when I look at h, I have something squared. Oh, that's 1 plus j. And I have 4 times something, so plus 4 times something. That's 1 plus j. And then minus, and again, be real careful about that. And h of 1, that is 1 squared plus 4 times 1, and all over h. So this is the limit as j goes to 0. I need to square out this first term here, so I get 1 plus 2j plus j squared. Again, if you don't multiply that out correctly, well, you're going to get a screwy answer. So plus 4 plus 4j, remember to distribute everything. So this is a lot of applied algebra and all this. So then minus 1 and minus 4. Now I could have done just minus 5 over h. Now, so here's a 1 and a minus 1. There's a 4 and a minus 4. And so I am left with limit as j goes to 0 of, what do we have here? I have a j squared and a 2j and a 4j, so plus 6j. And that is all divided by j. So I can factor out, j goes to 0. I can factor out a j on the top, and so I get j over j. That limit's going to be 1, and then times the limit as j goes to 0 of whatever I had left, which was a j plus 6. So we get 1 here, and when I direct substitute here, I get 0 plus 6, so I get 6. Quit that. Okay. So this is equal to 6, and that is the slope of our tangent line, or the derivative of h at 1. So h prime of 1 is 6. Okay. So I think we're done with that one.